Hello friends, I'm at your service with the second part of capacitor training in the previous articles. I introduced electrolyte capacitors to you. And in continuation of the topic of capacitors, the ceramic capacitor. The dielectric inside of which is ceramic. It is the same in electronic circuits that have two bases and are placed on the board in this way. The thing is, ceramic capacitors are very similar to multilayer capacitors in terms of applications, performance, and features, with the difference that multilayer capacitors have better performance. So I will explain these two together. Multilayer capacitors are like ceramic capacitors with the difference in terms of appearance. Both models exist in the form of dips, but SMT models are only available in the multilayer capacitors, which are in this form. Multilayer SMD capacitors have the same dimensions as SMD resistors. That is, they have standard sizes and are now based on the same sizes. For example, 100 nanofarad SMD capacitor 1206, that is, are determined based on the same standard that I told you about in the resistor section. And they are multi-layered and have different capacities whose thickness is determined based on their capacity and working voltage, which I will explain later. The next thing is that multilayer and ceramic capacitors don't have polarity. That is, they don't have separate positive and negative bases. So we show their circuit shape in this way. Regarding the type of dielectric, I said that the ceramic dielectric capacitors have ceramic plates in the middle, but the capacitor, the multilayer, is made of electrode layers and ceramics. Between each of these layers, pay attention to the capacity and voltage and how to read this model of capacitors. A three-digit number is displayed, for example, 473, where the first two digits are 47 and the third digit is 0 in front of the number 47, like SMD resistors, which are 47,000 but 47,000 picofarads. That is, all these capacitors, which are shown as three numbers, have a capacity of 10 to the negative power of 12 or pico. And this becomes 47,3 to 0, 10 to the negative power of the 12, which becomes 47 nanofarads. Let's read these together. See that 3910 becomes 390 picofarad. 10220 becomes 1000 picofarad. This is 4 and 7/10 of nanofarad. This is 10 nanofarads in the same way. For example, 47/10 to the power of 4/10 to the negative power of 12 becomes 470 nanofarads, or for example, 4700ths of a microfarad. It isn't written anywhere. Their model in this same. That is, their four sides are a cream color. And their capacity is not registered. And voltage is not a very important parameter in choosing these capacitors. That is, they are mostly based on their capacity. In the electronic circuit, one of the applications of multi-layer capacitors are called decoupling capacitors or bypass capacitors. In this electronic board, you can see multi-layer capacitors in different parts next to the microcontroller of different sizes. These capacitors are usually called decoupling or bypass capacitors that are placed next to these ICs. What behavior do they create now? Let's assume that the DC voltage is the power supply for these different parts of our circuit, which is a distortion or a high frequency noise. We want to stabilize this voltage in such a way that the operation of our circuit is flawless. So we put a multi-layer capacitor on this noise, which is on the line is damped or bypassed or decoupled by this capacitor and gives a smooth stabilized voltage to the IC. Therefore, they usually put a multi-layer capacitor of 1000 nanofarads next to the power supply of ICs. The quality and performance of multi-layer capacitors is far better than the ceramic model. About the price of multi-layer capacitors based on their application. They are not very expensive, and it can be said that they are the cheapest capacitors in the market. The next capacitors are tantalum capacitor. Tantalum capacitors or tantal capacitors are another model of capacitors that look like this. The deep and base model, which is in the shape of a drop. The capacitor body itself and their assembly models. They are like this, or they are golden, yellow, or black, and the bases are SMD. We must be careful not to confuse the deep models of tantalum capacitors with multi-layer capacitors in terms of appearance. Another point is that multi-layer capacitors don't have positive and negative bases or polarity. But these have positive and negative bases or polarity and have a line that indicates the positive base or the longer base. It is the same in electronic boards. A soldered tantalum capacitor that has a positive base. Or in SMD models, compare the dimension with the multi-layer SMD capacitors. Tantalum capacitors are much larger in size because they have higher capacities. Another issue about tantalum capacitors. There is a question about their size and dimensions. We said that the multi-layer models, which are 1206 or 805 in size, are the same as SMD resistors, but the SMD models of the tantalum capacitor series, like the electrolytic capacitor models, have standard sizes, like this capacitor, 22 microfarads of tantalum. Is it size A or size B? Is it size C? This size determines the distance between the legs. The polarity of the tantalum capacitor, as well said, means that they have a positive and negative base. So to these faces are displayed. But how are they recognized? If it is a deep model, the positive base always has a line that shows that it is a positive base, and it is also characteristic in this form. If it is an SMD model, it is the base that is positive. A line is drawn on it. Be aware that in electrolytic capacitors, the base with a line is the negative base. But in tantalum capacitors, the base with a line is the positive base. Because capacitors have polarity in both tantalum and electrolytic capacitors, if we are not careful, we solder the positive and negative wrongly. and the capacitor will be burned. What is a dielectric type of tantalum capacitors? There is a polymer material inside them, and inside this polymer material is a non-silver material. And because there is a silver inside them, they have high prices compared to other capacitors. And because of these materials, it makes them perform very well. That is, they have high capacities in a small size compared to electrolytic capacitors. For example, a tantalum microfarad capacitor is much smaller than an electrolytic microfarad capacitor with the same working voltage. Of course, they have better frequency behavior and are more stable with respect to temperature. What is the capacity and voltage and how to read it? In tantalum deep capacitors, it is written that their capacity is, for example, 4.7 microfarads, whose unit with microfarads, and the voltage was 35 volts. If there are 3 digits like this, which we have learned 68520 in picofarad, which is 6 and 80 of microfarad, SMD models are read in the same way, 47520 picofarad, which is 4 and 7/10 of a microfarad, and their voltage is, for example, 16 volts. But the voltage of SMD models is determined according to a table standard. For example, the literal voltage is 25 volts, and very high voltages don't have tantalum capacitors like electrolytic capacitors. Application of tantalum capacitors. I said that in terms of low capacities and low voltages. They are very similar to electrolytic capacitors. Their performance is the difference that they have smaller dimensions compared to these capacitors with the same capacity and voltage. And for tasks where we have low current draw, they are like feeding microcontrollers. The feeding of sensitive ICs is very suitable, and the same is the case of their stability against temperature changes. For example, in electronic devices such as mobile phones, small dimensions are required. They are used as a power supply filter. A 10 microfarad ceramic capacitor and a 10 kilofarad tantalum capacitor. This ceramic capacitor eliminates high frequency noises and distortions on the DC line. And this tantalum capacitor also stabilizes the low frequency ripple issue. That is, if the voltage, for example, is positive if the limit is increased a little, then this capacitor stabilizes and charges. If we have a voltage drop, this capacitor is discharged in a small moment, and we still have the positive voltage in the front of a constant line. In this board, we can see that this ceramic capacitor in these dimensions can be used for low ampere and voltage regulators. These tantalum capacitors are used in the input and output. In terms of price, tantalum capacitors usually have high prices compared to other capacitors. Well, so far we have introduced the capacitor. Then we will go to the polyester capacitor. Polyester capacitors have different models in terms of appearance, which you can see in the picture. Different dimensions, different voltages, and because they are very similar to MCOT capacitors in terms of performance. I will also give some explanations. Polyester capacitors and MCOT. The appearance of polyester capacitors is like this. They have different dimensions, different voltages and capacities, and different colors. The MCOT model is like this, a rectangular cube, and again different capacities and voltages. An important issue is that polyester and MCOT capacitors are only available in the market in the form of dips, and they don't have SMD models. And these capacitors don't have polarity. That is, there is no difference between their positive and negative bases. So we display the term in this way. Dielectric type of polyester capacitors. Polyester capacitors have a high voltage in terms of their voltage capacity. Electrolytic capacitors usually have a high voltage level in terms of voltage. Their dielectric in electrolytic capacitors is in the form of two conductive plates and a paper. It was wrapped and placed inside the cylinder of the capacitor. The polyester capacitor is almost the same, two conductive plates and a dielectric between them, which were wrapped, and a base was placed between these two. But the MCOT capacitor is made of sheet films. There is a sheet that is placed on top of each other in this way, and for this reason this model is also called film cap. Discussing the capacity and voltage and how to read these capacitors. Polyester capacitors with high voltage are written on them, in addition to the fact that this capacity is specified as 3 digits. Note that polyester capacitors don't have polarity and their capacity and voltage are also high. MCOTs are the same way. For example, this capacitor is 1 microfarad and its voltage capacity is 275 volts, and this one is 4700 microfarad and its working voltage is 275 volts. Let's go to their use. As I said, these capacitors have polarity. That is, they don't have a positive or negative base. Their working voltage level is also high, and they are used for high voltages and single phase and three phase alternating voltages. On these capacitors, the leads, ripples, and distortion on the AC voltage. This capacitor is placed at the input of devices that work with IC power. Another point is that their capacity is low because their working voltage is high. Their dimensions are large, but their capacity is lower. And we cannot use them as capacitor filters like electrolytic capacitors. In terms of price, they have relatively high prices. In the last case of the introduction of capacitors, I will explain special capacitors that I will only examine two cases of: supercapacitors or variable capacitors, which used variable capacitors in radios to modulate the frequency wave in such a way that the different plates of the capacitor increased and decreased, and the capacity of the capacitor changed. But in the case of supercapacitors, these capacitors can almost be said to be used more and more every day. The use of these capacitors is usually used as a batteries they become. I hope you have used this content. Follow me and please don't forget to subscribe.